In the last video, it was shown how to use variables to retrieve data from a planetary gearbox. Also, in previous videos were shown how to create logical conditions. In this video, we will show an example of how we can extract or retrieve real-time information from a motion simulation to interact with the process to modify it. For instance, read tables, check for collisions, or study the viability of a mechanism. In other words, how to use logical conditions to define a specific action. To illustrate this, let's create a circle whose value r depends on the value of the variable dist1, and then we are going to redefine this r variable using a logical condition statement. Let's create a variable r with an initial value of 20. During the simulation, the variable r must be set to only two values, for instance, 18 and 30. The value of r will be defined according to the value of the variable dist. If dist1 is greater or equal to 40, the variable r will be set to 30. Create this condition. Activate the if command, and use the expression dist1 greater than 40. Associate variable r with a value equal to 30. Then create an else condition. Associate variable r with a value equal to 18. Close the logical condition. Let's see the logical conditions in the list of commands. Create a circle with a radius equal to the variable name r. Indicate the diameter dimension and inform that this dimension has a parametric value. As it is a diameter, the expression is 2 times r. It is not necessary to insert this information in the dimension property, because the circle radius has already been defined with the variable r. Select the circle, right-click to open the menu selection, and edit the line attribute. Associate this circle with a fill attribute. For instance, with hatching type 0. Set the hatch distance type to 3. Note that this new construction was created after the last saved simulation command. Don't forget to move the simulation to the end of the list. Test the simulation. The value of the variable r is not changing. This occurred because we need to activate the option check parameterization in simulation dialog box. This option forces the system to retrieve variable values like the value of the variable dist1 and also test logical conditions during the simulation. Test the simulation again. Note that the variable r is modified to 18 or 30 only during the movement simulation. When it ends, it is returned to its original value of 20. Display a text showing the value of the radius equal to variable r. Now we are going to display a message every time the variable dist1 is less than 24. Remember, instead of displaying a message, it could be an action to abort the simulation, for instance. Indicating that a collision occurred. Define a logical condition. If dist1 less than 24, show a message. Dist1 is less than 24. Close logical condition. Now repeat the simulation and activate the option to show messages. Note that the simulation command was not saved with the option check parameterization and show user messages active. So every time the simulation is tested, we need to activate both options. See the result. But this command can be edited to set both actions. This way, we can create parametric variables fed according to the geometric conditions of the process. This represents the possibility of creating complex geometries in a very simple way and in real time. Remember that solid face drawing has the same function interface as the sketch module of the part and assembly environments. Therefore, everything shown here applies to the sketch module, greatly simplifying the task of learning the 3D environment. The sketch technique represents about 50% of the time invested in 3D modeling learning.